Okay guys, so this is going to be our guided notes for chapter 13. So we're going to start off with section 1, which is trigonometric functions in right triangles. And first we're going to define trigonometry, and then pretty much after this you'll hear me just call it trig, other than if I'm reading it off of your notes that I want you to see, because it's just easier to say it that way. So trigonometry is the study of relationships, among the angles and sides of a right triangle. So trigonometry is the study of relationships among the angles and sides of a right triangle. Then we have a trig ratio, which just compares the side lengths of a right triangle. So it compares the side lengths of a right triangle. And then a trig function has a rule given by a trig ratio or a trigonometric ratio. So that's just some definitions to get us started. So we're going to use this Greek letter called theta. It kind of looks like a capital O with a line through the middle. And it's often used to represent the measure of an acute angle in a right triangle. So it's often used to represent the measure of an acute angle in a right triangle. So we're going to use this triangle to talk about the different parts. So the side that is right beside it's touching the theta is the adjacent side. Side across is the opposite side, and then the diagonal across from the right angle, the longest side, is the hypotenuse. And we're going to use those to help us with these formulas kind of. So sine is, if you remember SOHCAHTOA, that's going to be really helpful here. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then to go from sine to cosecant, you flip it. So it'd be H over O. Cosine to secant is, you flip it, H over A. And then tangent to cotangent, you flip it, A over O. So we'll use that kind of like little formulas to solve. Okay, so for example 1, we're finding the values of the 6 trig functions for angle B. So that means we're from B's perspective. Theta is also right there to help you. So for sine, it's opposite over hypotenuse. So opposite of B is 15, hypotenuse is 17. Cosine is adjacent over hypotenuse. Adjacent to B is 8, hypotenuse is 17. And then tangent's opposite over adjacent. Opposite is 15 over 8 for adjacent. Cosecant, you just flip the sign, 17 over 15. Secant flips cosine, 17 over 8. And cotangent flips tangent, 8 over 15. So we found the 6 trig functions for angle B. Okay, so reciprocal functions, cosecant is just 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. How I remember this, cotan and tan, those go together, but CS, SC, it's always the opposite letter. Okay, so for example 2, we have if tan B is 3 over 7, find the value of sine B. So I'm going to draw a little triangle, right angle, and then tan would be, we'll put the B right here, it would be opposite over adjacent. So tan, opposite of B, would be 3, adjacent would be 7. If I want sine of B, that would be opposite over hypotenuse. Well, I have opposite as 3. So now I just need the hypotenuse. So it's a right triangle, so you do 3 squared plus 7 squared equals x squared. 3 squared is 9, 7 squared is 49, 9 plus 49 is 58 equals x squared, and take the square root. And then I would suggest, since this is a fraction, don't do a decimal answer. So like 58, see maybe it divides by 2. And that's 29. Well, if you broke down 2 and 29, There's no matches there. 29 is not going to break down any further. So we're just going to say that x is the square root of 58. So this would be sine b would be 3 over radical 58. We don't leave a radical in the bottom, so we just multiply it top and bottom. And so now our answer is 3 radical 58 over 58. And you can check and see if 58 will divide by 3. It doesn't, so there's nothing to reduce. So this is the most exact answer and the value that you'd want. But again, the idea here is just using what you know to find the missing side and be able to fill it in. So next is our special right triangles, and we've talked about these already this year, I think. If not, we talked about it last year. But these are worth memorizing for trig. The easier one is 45, 45, 90, because if these are both 45, then these are both the same. So whatever your side length is, you just multiply it by square root of 2, and that's your hypotenuse. If you know the hypotenuse, divide it by square root of 2, and that's your side. 30, 60, 90 is a little harder because you have 3 different amounts, like values. So for 30, it's across from the smallest side, which is x. Double that to get hypotenuse, or smallest side is x times radical 3 to get the 60-degree side. So again, special right triangles. Okay, so for example 3, if this is 60, that's 30, which means that is our small side. Across from 60 would be x radical 3, and then the hypotenuse would be 2x. Well, if 2x equals 14, that's an easy way to find x. I just divide by 2. X equals 7. So this side would be 7, which is actually what we were looking for. That's where x was. So that is your answer. And then for 45, that one would also be 45. So if that's 10, that's 10. And all we do is multiply by square root of 2. So x equals 10 radical 2. And that would be your hypotenuse. So again, it's so much easier using those special right triangles, and you get exact answers, no decimals. Okay, example 4 says to use a trig function to find the value of x and round to the nearest tenth. So what we know is we want this length right here. So across from 24, this would be the opposite, and then this would be the hypotenuse. So ka, toa, which one uses opposite and hypotenuse? That is sine. So the sine of 24 equals 11 over x, opposite over hypotenuse. So times x, and then divide by sine 24. So then I'm typing in my calculator. I'll show you. 11 divided by sine 24. And we get 27.0. It said nearest tenth. So 27.0. One thing to check just real quick, check your mode and make sure that you're in degrees, not radians. So you want to make sure if you're not getting that answer, that's what you want to check first, and it should stay there for you. For inverse trig ratios, you're just going to notice that they have these negative ones. That's just 1 over the sine, 1 over the cosine, 1 over the tan. Okay, and you use this when you're solving for an angle. How you use this on your calculator is you'll notice sine, cosine, tan right behind it is that -1. So you push second sine, and that's how it shows up. So that's how you would solve for those in the calculator. Again, you use this when you're solving for the angle. We were solving for a side on that last problem. Okay, so let's find the x, the angle, and again it says round to the nearest tenth. So for x's perspective, this is adjacent, this is hypotenuse. That's cosine of x, the angle we don't know, equals 15 over 17. We need to move cosine over, and that is when it becomes the inverse. So what we do is we type in second cosine, 15 over 17. And you could use a fraction button if you wanted. And we get 28.1. So x equals 28.1 degrees. For the next one, this is not drawn very well, but there's the right triangle, so that helps you know which one's hypotenuse. So x, this would be opposite, and this would be adjacent. So that would be tan, toa. So tan x equals opposite, 27 over 18 adjacent. Again, to move tan away, that gives you the inverse, tan of 27 over 18. So we type in our calculator, inverse tan, 27 over 18, and we get 56.3. So x equals 56.3 degrees. The next things to talk about are angle of elevation and angle of depression. Angle of elevation is just the angle formed by the line of sight and the line parallel to the horizon. Sight pointing up is how I like to think about it. And the angle of depression is the angle formed by the line of sight and the line parallel to the horizon, but your sight is pointing down. So if you're looking up, elevation. If you're looking down, depression. Okay, so a 14-foot ladder is placed against a house at an angle of elevation of 72 degrees. So I like to draw a little picture. It doesn't have to be anything spectacular. You know, whatever you want it to look like. Okay, so a ladder is leaning up. It's even with the ground, so that's a right angle. It says that the ladder is 14 feet long, and it says it's an angle of elevation, so we're looking up at 72 degrees. How high above the ground is the top of the ladder? So it wants to know this piece right here. So 72, this would be hypotenuse. This would be opposite. So sine, SOHCAHTOA. Sine 72 equals opposite over hypotenuse. So we multiply by 14 to get the x by itself. So I actually have my answer if I type that in. So 14 sine 72, and it's 13.3. And it didn't tell us one decimal place, but we'll just stay consistent with the last example. So 13.3, it did say it was feet, so I'm going to add in that unit. So that is section 1.